Geometry wasn't invented just to punish us in classroom. And a matter of fact, geometry was invented so people could keep up with their land. They were losing their land in ancient Egypt because of flooding. Every year, floods happened in the Nile and flooded their land, and they had to regain and remeasure where their land belonged. So if you can't prove your land is yours, you lose everything, right? So the Pharaoh hired specialists, and that's where we start with geometry back way before even Jesus came here. So, all right. So when we teach geometry today, what we do is we jump right in. We jump right into lines and angles and shapes, and we start doing math and teaching the math from formulas. But geometry came from a long time back. So when we go back to where it really began and what was going on, we're going to see why we needed geometry, what its point was, and we started covering that in the last week's video. Where we talked about why do we even have algebra, geometry, and even calculus, the story behind math. That's down there. So some of you have asked for more detail about these courses and what's going on here, a little bit more history. So we're here to deliver. So let's jump into geometry, though. Let's just jump into the beginnings of geometry and put this in perspective of what was going on. So we had a old kingdom Egypt pharaohs, right? So 2700, 2200 BC, the era of the Great Pyramids. Now, put in perspective, Abraham was called from Ur around 2000 BC. So this is before, Abraham and his family are still in Ur. So that's where we see the era of the Great Pyramid builders. So under Pharaoh Djoser, which was, we're going to guess, around 2670 BC. That's not my guessing. That's people who know what they're doing is guessing. He had an architect, Imhotep. I'm probably butchering that, but he built a step pyramid, the Saqqara. Might be butchering that name too, but so he built that step pyramid, and I'm guessing this is one of the first pyramids. And you don't just stack 6 stones together and make a pyramid without understanding some angle and alignments, and ratios. If you've even just seen trying to do home projects or trying to just kids out there playing, when they start stacking things together, building things, it gets out of hand really quick if you don't have some thought about what you're doing. So this was the early geometric engineering that was going on. So, and then under Pharaoh Khufu, I think is how you pronounce his name, around 2500 BC, the Great Pyramid was built. The Great Pyramid. This is the one we often think of and the one we see in pictures all the time. Now, its longest and shorter sides differ by less than 8 inches. Now, that's across a base of about 755 feet. That's an accuracy of, that's very accurate, 1 in 1,000 accuracy, essentially. The alignment to true north is within 0.05 degrees. 0.05 degrees. Now, this is GPS level alignment. So now think about something. Nobody builds with that precision without some math and measurement and thought about it. Imagine laying out a structure longer than a football field. Right? Longer than a football field and missing by less than the width of your hand. That's what we're talking about. For perspective today, even with laser-guided surveying and with all the equipment that we have, large commercial projects might vary by an inch or maybe even more over 100 feet. And if you've ever had to do modifications to a building, where a home or a commercial building, that they're not always perfectly built, and they're not always square. Measurements are not always perfectly accurate. Things are just not perfect. That's with modern equipment. The Egyptians achieved less than an 8-inch difference over 755 feet, an accuracy that is still acceptable. So that's pretty awesome. This geometry was there before the word geometry even existed. Right? We didn't even know what it was. So the problem though that is when we kind of get into what we think of as normal geometry is still going on in Egypt. Is one of the big problems that they had was they had floods along the Nile. Every single year we had floods. And it would wipe out property boundaries, right? If you're a farmer and you have property boundaries and you may have fences and things, but even if you didn't have a fence, you care that, okay, well, where I was farming and where I am farming now, because the property moved, my property moves back and forth. It became a real problem. I mean, they were taxing property and doing all that kind of stuff back then, just like we do now. So Egypt created, the Pharaoh of Egypt at the time created a class of specialists. They called them, I'm going to pronounce, Harpindonapes. We'll put the spelling in there for you, let you figure that one out. But essentially it translates to rope stretchers. That's what they were. They were rope stretchers. And what they did is they would have these ropes and they would have knots tied at even proportions to help them lay out and take measurements. So they would lay out straight lines. They would mark right angles because they would have a knot on some rope that a knot went 4, we'll call it feet, but 4 feet in one direction, 3 feet in one direction, and 5 feet in another. And if you know there's a 3, 4, 5 right triangle, 3, 4, 5 right triangle, one of the ones that we memorize for the ACT and SAT, that triangle would help them know where there was right angles, and so they could figure out where there were the right angles to mark the property lines, and they would remeasure every field, and that helped the pharaohs establish fair taxation, if taxation is ever fair. But that gave them taxation of the property lines, right? So we have records in the Wilbur Papyrus, which was about 1147 BC. Last I looked was where they have list of measurements of fields and owners and tax rates. Now this would be much like if you go onto the website and look up your city and county or state and looked up your property. They have your name and they have the measurements where your property is located, who owns it, and maybe tax rate, some tax rate and some tax information. It's very much like that. Or if you look up a property on Zillow, it's that kind of information they had on this Wilbur Papyrus back in 1100 BC. Right. So geometry in its original form was measuring land, and so your society didn't collapse because you were constantly having arguments over who owned what. So it was a practical tool. So now let's put this in context for just a minute before we jump around. So as I said, Abraham about 2000 comes from Ur, about 1800 to 1400. The Egyptians, the Israelites are in Egypt. We're thinking Old Testament, and then in 1400 or 1446 BC, that's when the Exodus happens, when the crossing of the Red Sea and Moses. So a lot of this happened before then, but we have evidence. Obviously, what was going on in Egypt. They were obviously a very powerful nation. And because we see so much of that in the Old Testament. And so what we're seeing here is at the same time Israel is growing up, and we're our characters in the Bible that we know of in the Scripture is we see this stuff going on right there next to them. They're next door neighbor just to the south. So about 1000 BC, we see King David and King Solomon, and what do? They build a temple with skilled craftsmen, right? So think about this for just a minute. So by 960 BC, so now this is after the pyramids are built and the rope stretchers are there, and the Egyptians got these great records, and they're using practical geometry, right? When Solomon built the temple in 960 BC, the Bible talks about some very detailed measurements. And so if you're not even into the Bible, if you're not a believer, you can go look at this and you'll see it over and over. You'll see it in First Kings and First Chronicles, where you are given very specific length, width, and height measurements, and very detailed wall thickness, side rooms, perfect cubes. And they talk about the most holy of place, and there's this endless amount, as if you've ever read this, endless amount of detail about building the temple. I mean, it's incredibly detailed. So what King David had done is he had all of this stuff ready for his son, King Solomon, to build it. He even gathered all the resources. And he talked about gathering. They have a section in there where you're talking about the craftsmen used. Right, they were hiring people skilled in trade, right? So skilled people. So craftsmen use tools like geometric plumb lines, geometry, measuring cords, sounds kind of like the rope stretchers, stone setting levels, right? So where do you think a lot of this came from? Probably Egypt. These are not poetic descriptions in the Old Testament. These are very detailed architectural instructions. So the Phoenician builders who helped, you see in 1 Kings 7, the Phoenician builders were known across the ancient world, so that we knew what they were. We knew that they could do this for precision and symmetry. And they used the same kind of methods that we saw in Egypt. So when we read about geometry in Egypt and then read about it, the construction of the temple in the Bible, it's the same world of engineering. Maybe some of the same people groups, or different years, obviously, but some of the same training that's been handed down to people to build one thing or another. So these were real builders using real geometry. This is what's going on. This is you see it going on in Egypt, and you see it going on over here in Israel also. So now let's jump in. Let's jump in here before we jump into, because what happens is from Egypt, who built, we're going to call practical geometry. And then the Greeks systematized geometry. They built a system of mathematics around it. So let's put this, give you some kind of time frame here. Is what's going on here is Alexander the Great. We think of, as most of us know about him. So he's around 356 to 323 BC. And he conquers everything, including Israel and including Egypt. So his empire, one of the things it did, it spread Greek language. When we hear Hellenistic, Hellenistic or Hellenism basically means Greek culture. So it's Greek language, Greek education, scientific thinking. He was a student, Alexander the Great, a student of the great Egyptian thinkers. So now we see this everywhere, and he was very adamant about pushing Greek Hellenism or Greek thinking all over the world. So now we see Greek everywhere that's going on. Now this matters because now everyone shares a common language, Greek, and mathematical ideas can kind of move freely across nations, and that's where we see a few decades later, Alexandria in Egypt becomes the intellectual capital. Alexandria in Egypt is the intellectual capital of the world. So a lot of this is because of Alexander the Great. And after Alexander dies in 323, his general, Ptolemy, so if you know your history, Alexander the Great had 4 main generals, and the world broke up into 4 main parts, Ptolemy being one of them, and Ptolemy took Egypt, or that Egyptian area. And he builds the Library of Alexandria, where scholars mix Egyptian measurement traditions with what we get in Greek logic. So, all right, so let's talk about how, where we get some of this. We got a couple of main characters here. Thales traveled, so he was Greek, so he travels to Egypt to learn practical geometry. He's the one that's famous for measuring the height of the pyramids by the shadow. right? And then we see Pythagoras, or not where we know the Pythagorean theorem, studied with Egyptian priests and formalized geometric relationships. So this is all going on about this time. And then around 300 BC, just after Alexander's empire had reshaped the world, and he's gone now, and then there's the four generals, and we are in, we're kind of in this time between the Old and New Testament, right here, the intertestamental period, because Alexander the Great and some of these kingdoms, they were in the battle where we see Maccabees and all this kind of stuff going on, lots of conflict. So around this time, Alexander's empire had reshaped the world. Euclid wrote a manuscript calling the Elements in Alexandria, and it was under Ptolemy. So all of this happens, again, in the intertestamental period between the Old Testament and the New Testament. So at this time, we see Greek becoming the dominant language, and that's why the New Testament is written in Greek. And we see, of course, Greek influence in things for many years to come after that. So this is what we see, how we get geometry and where it was all developed. And what we think about today, Euclid, his manuscript on the elements is essentially what we teach today. I mean, it's a big part of what we teach in geometry, wherever you learn geometry. And it's a big part of the things we just take for granted, right? Things that we just know, areas and things that just logical everyday geometry that we don't necessarily think about as geometry, but it is. And then we see things like logic. Now, Euclid also was big, and the Greeks helped to turn geometry into logical thinking, which if you've ever done debate, or you've done or you've taken a course in logic, and the fallacies and things like that, they all come out of geometric thinking, which that may be weird because we're now talking about arguments, right? But when you do a proof in geometry, that's the basis of modern day logic, which we see in politics and debate and things like that. Well, we would hope some logic is in politics, but that's a whole nother issue. So even though the world has changed and we have a lot new technology now, the core problems haven't really changed, right? Geometry still helps us to do building with straight lines. It's important to have a straight line. It's important to have land divided fairly. We still have arguments about that, and we have better tools about that. Oddly enough, a surveyor, and if you read a blueprint and surveying, or if you look at a surveying map, we have some really old-fashioned things, like it will say sometimes on a survey, the corner is at a knot in a log, which is how weird is that? But we still see that. I was dealing with that not too long ago myself, and what a weird way to mark a corner, right? Are we really an advanced society? But we're doing a lot more things now with GPS coordinates. So we're trying to divide land accurately. But where does GPS come from? Where did we get this? Where did we get the idea of throwing satellites on Earth, and how does that give us precise measurements? Geometry is a big part of that. What essentially these satellites do is they shoot a signal down to your cell phone, and your cell phone is getting a signal from multiple satellites at one time, and we know where the satellites are, and because we can measure the time difference, how of these things coming down to you, we now can measure the shape of the triangle, essentially, that you are, and that helps to pinpoint your location. So we're still using it today for much the same reasons, just with different technologies, which is how technology often moves ahead. It solves the same problem with the same tools, but it just updates the human interface to it, or how we see it and how we use it. So the Egyptians used knotted ropes. We use lasers, right? Same math, same purpose. So as your students are sitting there banging their head against the wall doing geometry. I hate this. This will never be used. There's no point in any of this. Well, it's used every day, and it's always been used every day. And it solves real problems for real people who care about things like making a living and knowing where their property is marked. And we kind of like buildings built so they stand up stronger and better. And when we redecorate our house, we can take good measurements and things lay out like they should, right? And we struggle, but our struggle oftentimes with math or in knowing anything, for many of us, even those that may not consider ourselves intellectually curious, we just like to know why. Where does this come from? What's the point? What's the point of this? So that's why we're doing this, is to help you know whether you are a student. We're all always students, right? That never changes. But whether you're a student actually in a class taking geometry, or whether you are a teacher or a parent trying to help guide through, that there's a point to this stuff. There's always been a point to this stuff, and it solves real problems.